Hello good day viewers. In this tutorial we are going to integrate this function 1 divided by the square root of 1 plus x squared with respect to x. Alright, let's get started. Before we start, I would like to remind you about one trig identity which stated that 1 plus tangent square theta is equal to secant square theta. Hence we can replace x with tangent theta, right? So let x be equal to tangent theta. If we differentiate both sides, we have the x to the left, and this is equal to the derivative of tangent theta, will give us secant squared theta d theta. Right? So let's back substitute. The whole of dx will become secant squared theta d theta times 1 is still secant squared theta d theta. So to the top we have secant squared theta d theta divided by the square root of 1 plus x squared, but x is tangent theta, which we can now replace x with, so it becomes tangent squared theta, right? So we have the integral of secant squared theta d theta divided by the square root of secant squared theta, because I told you 1 plus tangent squared theta is secant squared theta. So the square root and power of 2 will cancel, right? Leaving secant theta. As we move on, we have the integral of secant squared theta d theta divided by secant theta. And secant squared theta divided by secant theta is just secant theta. This is equal to the integral of secant theta d theta. So what is the integral of secant theta d theta? It is nothing but secant theta tan theta plus secant squared theta. But let me show you how. You know, we can rationalize this as divide by 1. It won't change anything. And for equivalency, we are going to multiply the top and the bottom by secant theta plus tangent theta. So we have the integral of secant theta multiplied by secant theta plus tangent theta divided by secant theta plus tangent theta d theta. You know, this won't change anything because this divided by this is 1. And if we distribute to the top, we have secant theta times secant theta is secant squared theta plus secant theta times tangent theta divided by secant theta plus tangent theta d theta. So I would like to let the denominator be equal to something else. For example, we can let v to be equal to secant theta plus tangent theta. Then if we differentiate both sides, to the left we have dv, and to the right hand side, if we differentiate secant theta, we are going to obtain secant theta tangent theta plus, if we differentiate tangent theta, we're going to get secant squared theta d theta, right? So you can clearly see that to the top we have exactly secant squared theta plus sec theta tan theta, which we have here. Now we can replace it with dv, and the bottom is now going to be v, right? So we have the integral of dv divided by v, which is equal to the natural log of the absolute value of v. But what is v? We are going to substitute it back as what? Secant theta plus tangent theta, which is equal to the natural log of the absolute value of secant theta plus tangent theta plus the constant of integration. But we are not done yet. Remember, our original function was in terms of x, but this is in terms of theta. So how can we bring it back? All right, from this equation here, that we have let x to be equal to tangent theta. So wherever we have tangent theta, we are going to replace it with x. So we can replace this with x, but what about secant x? Let us form a right angle triangle here, where this is our theta. Tangent theta is what? Opposite divided by the adjacent. So we can rationalize this as x divided by 1. It doesn't matter. So the opposite is here and the adjacent is here. What about the hypotenuse? It is going to be the square root of this squared plus this squared, right? So it is going to give us square root of x squared plus 1, or 1 plus x squared, all the same. So what about cosine theta? Because I know secant is just the reciprocal of cosine. So let us get cosine first. Cosine theta is equal to adjacent divided by hypotenuse. That is 1 divided by the square root of 1 plus x squared. I told you they're all the same, commutative. Then secant theta, all you have to do is to take reciprocal of both sides. Taking reciprocal of the right hand side, it will give us just the square root of 1 plus x squared. So we are going to back substitute. Let me just copy this. All right, to back substitute, this is equal to natural log of the absolute value of secant theta, which is now square root of 1 plus x squared, then plus tangent theta, which is what? X, plus the constant of integration. And hence this is the solution to that integral of 1 divided by the square root of 1 plus x squared with respect to x. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.